The reconnaissance is done. You have a map. You know which server is running an unpatched version of Apache with a known CVE. You know the VP on login URL. You have 3 employees' credentials from a breach database, and one of them hasn't changed their password since the breach was published in 2021. Now comes the part the movies get wrong. Exploitation isn't a single dramatic moment. It's methodical. It's patient. It's a sequence of tools and techniques designed to establish access, deepen it, and maintain it without creating enough noise to trigger an alert. Part 2 of the hacker's toolkit. What happens after reconnaissance ends? Metasploit is the foundational exploitation framework. Open source, maintained by Rapid7, used by penetration testers worldwide and included in Kali Linux. It contains over 2,000 exploits organized by CVE and platform, along with payloads, the code that executes on the compromised system, and auxiliary modules for scanning and enumeration. A penetration tester identifies a vulnerable service, selects the corresponding exploit from Metasploit's database, configures the target and payload, and executes. Metasploit handles the low-level exploit mechanics. If successful, it delivers a meterpreter session, an interactive shell with memory-resident execution that doesn't write files to disk, making it harder to detect with traditional antivirus. Cobalt Strike is the commercial alternative, $2,500 per license, targeted at red teams and professional penetration testers. Its beacon payload is a sophisticated command and control implant that communicates with attacker infrastructure using configurable, malleable profiles, network traffic patterns designed to mimic legitimate software. A beacon configured to look like Office 365 traffic or Google Analytics is significantly harder to detect than a generic backdoor. Cobalt Strike is so effective that cracked versions have been distributed widely and are used by multiple nation-state threat groups, North Korean Lazarus Group, Chinese APT41, and various ransomware affiliates have all been caught using it. The tools the professionals use become the tools the adversaries use. Privilege escalation is what happens after initial access. An attacker who lands on a workstation as a regular user has limited capability. The goal is to escalate to administrator or system level, which allows installing software, accessing other users' files, and controlling the machine completely. Common privilege escalation techniques include exploiting misconfigured services running as SYSTM, abusing group policy misconfigurations, token impersonation in Windows, and exploiting unpatched local privilege escalation vulnerabilities. Tools like WinPES and LinPES automate privilege escalation, enumeration. They run on the compromised machine and output a prioritized list of potential escalation paths based on the system's specific configuration. Mimikatz is one of the most consequential tools in the offensive security arsenal. Written by Benjamin Delpy and first released in 2011, it extracts credentials from Windows memory, specifically from the LSASS process, which manages authentication and stores credentials in memory for single sign-on purposes. Mimikatz can extract plain text passwords, NTLM hashes, and Kerberos tickets from memory. With admin access to a machine, running Mimikatz against LSASS yields the credentials of every user who has recently authenticated to that machine, including domain administrators if they've connected to it. A single compromised workstation where an IT administrator has logged in becomes a domain-level compromise. This is why Microsoft has built Credential Guard specifically to protect LSESS memory. Lateral movement uses the credentials and access gained to spread through the network. Common techniques include pass the hash, using an NTLM hash without cracking it to authenticate to other systems, and pass the ticket, which uses stolen Kerberos tickets. PSExec executes commands remotely on other Windows machines. WMI and PowerShell remoting are legitimate administrative tools that attackers use for lateral movement because they blend in to normal IT activity. The goal is reaching high-value targets: the domain controller, the file server with sensitive data, the backup server. Each machine reached potentially yields new credentials via Mimikatz, enabling access to the next machine in the chain. Persistence mechanisms ensure the attacker maintains access even if the compromised machine is rebooted or the initial entry point is patched. Common Windows persistence techniques. Scheduled tasks that run the malware on system startup. Registry. Run keys that execute code at login. Windows services that start automatically. WMI event subscriptions that trigger malware on specific system events. The tradecraft choice depends on stealth requirements. A scheduled task is visible to defenders who review Task Scheduler. A WMI event subscription is more obscure. Attackers targeting high-security environments use techniques that are harder to detect. DLL hijacking, COM, object hijacking, at the cost of implementation complexity. Living off the land is the philosophy behind staying hidden. Rather than deploying custom malware that endpoint detection can identify, sophisticated attackers use the tools already present on Windows, PowerShell, WMI, SearchUtil, RexV Air32, Imshta, Rundle32. These are legitimate system utilities. Their presence doesn't trigger alerts. Their execution is logged but looks like IT operations. The technique is called LOBAS, living off the land, binaries and scripts. There's a public database cataloging every Windows binary that can be abused for offensive purposes, maintained at lobasproject.github.io. Defenders use it to understand which native tools require enhanced monitoring. Detection evasion at the endpoint level involves bypassing or disabling EDR, endpoint detection and response. Advanced attackers target EDR agents directly, patching specific functions in memory to blind the EDR to certain activity, loading kernel drivers to operate below the EDR's visibility, or using techniques that the EDR vendor hasn't seen and hasn't written detections for. This is the cat-and-mouse dynamic at the frontier of offensive and defensive security. EDR vendors push new detections. Attackers develop new evasions. The cycle continues. The practical implication for defenders is that EDR is necessary but not sufficient. Network-level detection and behavioral analytics provide different visibility. The toolkit is documented. The techniques are published. The CVEs are indexed. And yet organizations are compromised every day using methods that have been public knowledge for years. The attacker advantage isn't secrecy of technique. It's patience, persistence, and the asymmetric cost of defense. Defending requires getting everything right. Attacking requires finding one thing that's wrong. The tools in parts 1 and 2 are what penetration testers use in authorized engagements to find that one thing before the attackers do. If you want to understand what it looks like to use all of this in a professional, authorized context, with real clients, real scopes, and real reports, our video on penetration testing as a career covers the full picture. Knowing the toolkit is one thing. Using it inside real scopes, for real clients, with a report at the end is another. Penetration testing as a career covers what that profession actually looks like. It is on this channel.